Alright, so in this video, we're going to be building out the train and validation splits for our 5-second intervals of audio. So we're going to be building the data directory. And it's going to look just like this. It's going to have all of our files in it. And so we're going to have to build for the podcast, and then we're going to have to build for the environmental sound data set. So I'm going to go ahead and delete this now. And we'll start creating it. So let's start by grabbing all of our podcasts that we created. Actually, we could come up here, copy this line, and we're going to actually sort these because order is not guaranteed. And we're going to list all of our WAV files that we just created. And we're going to create two separate things. We're going to create a train path and a validation path. So this is going to be OS path join of UMX path. We'll be looking at, so we're going to build that data directory that I just mentioned, train and podcasts. And then we'll have a validation path, which will be equal to pretty much the exact same thing. Now we'll call it valid and podcast. Let me make some. So now we're going to use, we're going to create a train test split for our different podcast names. So we're going to call it train FNs and valid FNs. And we're going to be using what's called train test split from scikit-learn. You guys should have imported it at the top of the file here. And it can take a list or like a data frame, and it will create a train test split for you. So I'm going to give it the podcast that we just listed. So this is going to be 10 files, and it will consistently split this the same way every single time. So we just have to give it a test size of 0.2. So it's going to be 8 podcasts to train with and then 2 to test with. And our random state is going to be equal to 0. And this is why I like using train test split, is because it lets you set a random state. So every time you run this, it's going to be the same split of data. And we could actually take a look at these if we wanted to. So now what we're going to do is we're going to iterate through our train and our validation directory, and we're going to start to split up our WAV files into their intervals. So we're going to say for split file names in the zip, and we're going to zip 2 things. We're going to zip train and valid. So those are our 2 directories that we're trying to traverse. And then we need, so because zip is going to need equal length iterators to go over, we'll put our train file name, so, and our validation file names. And now we're going to specify an interval, and our interval is actually going to be equal to our sample rate, which was 44,100, and we'll multiply by the number of seconds, which is going to be 5. So we're going to have 5-second intervals as we move along our audio file. We're going to break it up, and then we're going to save them. So for file name in TQDM of FNs, because we would like to see a progress bar for this as it goes along. I'm going to say wave path is equal to path join of UMX path, JRE podcasts, wave file name. Actually, I kind of want to see what this looks like at this point. Make sure I haven't made any errors. So we're going to run, yep, there we go. So it actually ran the previous stuff that we wrote, but it skipped right over it because the paths already existed. And you can see these are all of our train wave files, and these are our validation wave files, and you can see a progress bar for when it goes and iterates over those. Now that's going to slow down a lot once we start doing some stuff, but let's get into it. So first we're going to read our wave file. We're going to say rate wave is equal to wave file dot read our wave path. So we're going to read those wave files that just printed out, and we'll say wave is equal to, oh, and this is something that I did. This is totally by my choice. So the Joe Rogan podcast always has the same like 10 or like, I don't know, 5-minute introduction, and I wanted to get rid of that, so because it felt really redundant. So I actually cropped out the first 10 minutes of every single audio podcast. So that's what I'm doing here. You don't have to do this, obviously, if your data is a little different. And we're going to set up a stop interval. So this stop interval is going to be the shape of our wave file. So it's going to be the total duration of the wave file divided by an interval. When you use double division in Python, that will round it down to an integer. And then we're going to multiply by our interval. So basically we just truncated the shape and then we re-expanded it by intervals so we don't get a floating point, so that we get a clean stop integer. So for I in range, it will start at 0 and we'll go all the way up to stop minus interval, and we'll increment by interval, so 5-second chunks. And we'll create a sample, a wave sample, and that'll just be equal to wave from I plus interval. And we will create a save directory. So the directory we actually want to save this into is umx path data, and we are going to do this for each split. So the split is actually up here, so it'll be train and validation. So we're going to make 2 directories, train and validation, and we'll go into podcasts. So now we are going to, again, we'll use check directory because these directories don't exist yet. So we're going to check it, see if it exists, and make it if it doesn't. And then we're going to create a file name. And the file name, we're going to do file name.split. And we will split on our period again so that we can actually get the name. Because right now file name is .wave. It has that .wave extension. We can get rid of that. And we're going to create an integer for each wave. So the first one will be 0, 1, 2, 3. You guys get the point. And I is going to be equal to the int of I divided by interval. And then we'll create a save file name. So this will be the name of our wave file that we want to save. And this should be the string of os.path.join of save directory. Now we're going to take our file name. So file name is I guess it's the whoever's talking. So this would be something like Bob Lazar, and then we'll add on underscore wave, but we need to put in our I that we have here. So do I.wave. We'll use string formatting, so we'll format our I. That's interesting. Do I not need to convert this to a string? Maybe I'll just convert it to a string just to be safe. Okay. So if, again, if os.path.exists of our save file name is true, so if this already exists, I actually don't want to repeat that work. I'm just going to continue iteration. And then I'm going to say wavefile.write, and the arguments for this are file name. That is going to equal to savefn. And then we'll specify our rate, and that should be equal to our source wave, which we read in right up here. So that's this rate, which is going to be 44.1 kilohertz. And our data is going to equal to sample. because that's that sample that we just generated when we split our WAV file. All right, so let's actually see. Maybe I'll run it without the string, see what happens. Let's see if this runs, and we'll see what happened. And I'd imagine, okay, this is pretty fast. So it's going through all those files, and it's splitting up that really big WAV file into train and validation splits. And it's going to do the first one. We can actually check it out. So if I go to, now we have a data directory, so it got created. We've got a validation directory. It made a podcast directory, and within that, we've got all these train stuff. Or I guess, sorry, this is the validation, but these are all the little 5-second samples that we just created. In fact, you could take a look at it. Cool. So it'll do this for validation. It'll do it for training. And that's your podcasts. Starting to split up. All right, so now we're going to start to iterate over the ESC data and creating train test copies for all the different classes. So let's start by reading in the CSV file. Now I have it, so if you were to go ESC50 meta, you'll see the CSV file. Have it open over here. And so the important columns that we're interested in are file name and category. So let's start. Basically, these are already like in 5-second intervals. So all we're going to be doing, it's a little bit different. We actually want every single class to be equally represented within our train and our validation split. And so there's 50 classes and then there's 40 samples per class. So we need to create a train validation split for our 40 files. So 36 of them are going to be train, and then 4 of them are going to be test, right? So that's what we're going to be doing here. So we'll start by creating a data frame. So we're going to say pd.readcsv, and that file is located ESC50 meta ESC50.csv. And we can actually print our data frame here. And we want to get our classes. So from our CSV file, we want to get a unique list of all these categories. So the way to do that would say interders equals numpy dot unique data frame dot category. So we're going to grab the category series, convert it to a list, and we'll get these interfering directories. So we could actually print that. And let's actually go ahead and run that just so you guys can see it. So when we look at that, here's your data frame. We've got the first 10 entries, file name, category, and then these are all of our unique categories. So this should be all 50 environmental classes that we're going to be looking for. So let's start by iterating over those categories that we just created. So for the cat in interders here, let's make a little progress thing. So I'm going to say copying files from directory. So we're going to copy from this category. And we're going to create a data frame that only contains data of this specific category that we're iterating. So we're going to index our data frame. So we're going to say data frame where data frame.category is equal to cat. And then once we make a smaller data frame, because we want each class to be equally represented in the train and the validation. Like we want 36 examples of an airplane, and then we want the other 4 remaining files that are unique to be part of the validation split. So that's what we're doing here. We're just creating a train split and a validation split. But just this time we're using data frames. So we're using that same train test split that we used right up here, but we're going to be doing it for data frames. And so our data frame that we want to split is the data frame just created, data frame cat. And our test size is going to be equal to, this time I'm going to make it 0.1. So it's going to be like 36.4. Okay. And again, we'll use random state equals 0. So now I'm going to say, we're going to do, I think it's actually the exact same. It's close. So for split and split data frame. So we're going to be iterating a string, make it over here. So we're going to iterate this string, and then we're going to need our data frames that we just created. So it's going to be train data frame, valid data frame. Let's create a directory path. So the directory path is going to be equal to I think I just called it interfere. I really don't like the word interfere. Like interferer is just a really, I mean, I guess it's grammatically correct, but it's very awkward. It's a weird word to say. So we're going to check if that directory exists. So for each split, we're going to make kind of like our source. It's going to be interfere. And then we're going to iterate splits and save our wave file, because you guys remember, like when we looked at ESC50, all of our audio is already in 5-second chunks, and they're all just sitting in this directory. So what we're going to do is we're going to pull from here and copy them as they're kind of defined within this data frame that we just created, these train and validation data frame, right? So in order to do that, we're going to need to iterate that. So for I row in split data frame, and we're going to use the iterRow method. So if you've never used this before, basically row itself it's kind of like a series almost, or I guess it's kind of like a data frame where you can access a series. So I don't know the actual data type, but it's some weird pandas thing. So basically, if I wanted the file name, I would say row file name. So just like I went into this data frame, I want the file name. That's how you can grab it. And I'll say file name path is equal to my dir path, and I'm going to go into the file name because, like I said, they're all located at this. Well, actually, no, this is going to be the save. So this is going to be where we save our file name. And if os.path.exists, a file name path is true. Again, if we've already run this before and it already exists, we're just going to continue. But if it doesn't, we're going to create, we're going to copy it. So basically we're saying, if this doesn't already exist within my split data, I'm going to copy the file name that I need from here, and I'm going to drop it somewhere where it needs to be, directory it needs to be. So src path is going to equal to umx path esc50 audio, and then our file name. and then we're just going to do a copy. So if you're in Windows, then you should probably use Shuttle. It's this library. It should already be built in, but I think Shuttle has something like a copy method that lets you copy files over from file paths. But this would be CP. So we'll drop our two strings in there, and we'll do string formatting. So we should copy from our source and put it in our destination, which is called file name path, since it doesn't already exist. So let's actually run this, and we'll see what it does. There you go. It's copying every single directory. So it's going to do this for all 50 classes. And let's actually take a look at what it's doing. So if you guys go into data, you'll have go into validation. We've just created this interfere directory, and all of the samples are getting copied into it, which is really good. And so there should be exactly 4 files for each class in this validation split, and they'll be completely unique. Like, they will not be found in this train. This is where the other 36 for each class will be located. And so you create like balanced train test split. Sound good? So that's actually everything you need. All of your data is pre-processed. It fits, like if you were to go back and look at this file structure, this is exactly what we just built. And so at train time, it's going to randomly like pull in all the components, add them up to create a mixture of the signal, and then that's what's going to be passed to Open Unmixed so that it can produce whatever output, whatever target output. So notice how here the target is vocals. Now it's going to be podcast. It's going to be whatever 5-second interval it wants to match up that was up here. And yeah, that's how you create the directory for all this stuff. I know pretty boring stuff, but in actuality, like a lot of machine learning is moving data around in directories and then creating pipelines to go into models. So a little boring, but at this point in the next video, we're going to be training on, actually we're going to be training an Open Unmixed model, and we'll be making like some plots, and I'll be talking about like GPU memory utilization, all that stuff. So the next video are going to be start doing some interesting stuff, and I'll see you guys there.